Today we are going to cover chapter 1 of ninth mathematics, which is number systems. In number systems, we will cover following topics: real numbers, integers, whole numbers, natural numbers, rational numbers and irrational numbers, surds, rationalization of surds, rationalization factor, monomial surds and binomial surds. Then in our next video, we will cover solution of 1 mark and 2 marks question. Let's start with our first few topics. Here is our first topic, real numbers. Let's see the definition of real numbers. The set of rational numbers along with the set of irrational numbers form the real number system, and it is denoted by R. What is integers? So without decimal numbers like 1, 2, 3, 9, 10 till infinity. 0 is also an integer. Along with that, if we start from the negative side like -1, -2, so on, -9, -10 and until infinity. You can also denote integers as I or Z. The third topic is the whole numbers. So all integers starting from 0 until infinity like 0, 1, 2, 3 till the point of infinity. So you can say all positive integers along with 0 is your whole numbers. What is natural numbers? Integers starting from 1 until infinity like 1, 2, 3, 4, so on, 10, 11, 100, 101 and until infinity. In simple way, you can say integers starting from 1 is considered as natural numbers and it is denoted as n. Then what is rational numbers? A number that is in the form of p by q and can be in a form of p by q where both p and q are integers and q cannot be 0. That means your denominator cannot be 0, but your numerator and denominator both should be integers. Also, there is one more condition for the rational numbers. P by Q should be either terminating decimal or a repeating decimal. Let's take an example. Let's start with our first example. 9 by 15. How can we solve this? 9 divided by 15. If we see, first we need to put 0, then first decimal. It will give a value of 90. Then in a table of 15, 15 6 the 90, and then we have a remainder 0. So if we get a remainder 0, then we call it as a terminating decimal. In our second example, which is 18 by 22, like 18 divided by 22. So 22, 18 cannot be divisible. Then we first put 0 dot. With this we get 0. Now with this 22, 8 times 176. Remainder 4. Because of this decimal got 0. Now in 22, again we got 18. With this decimal 0. Then again 8, 176. We got 4 and then again 0. Similarly it goes on in a similar fashion, 1, 8, 1, 8 and 1. right? So here you can see the same pattern follows: 8 1, 8 1, 8 1, and 8 1. You will never get reminder 0, but you will get this pattern: 8 1, 8 1, 8 1, 8 1, and so on. So this is you called repeating decimal. So if there is any number which is in the form of p by q, like 9 by 15, which is equivalent to 0.6, and this is a terminating, your p is integer, your q is integer, and q is not equal to 0, you call it as a rational number. The next one is 18 by 22. Similarly, 18 by 22, you can write it like 0.81, 81, 81, and so on. Because your p is integer, your q is integer, and q is not equal to 0, then the next condition is it is a repeating decimal, then again you call it as a rational number. Now let's talk about the other form of numbers, which is irrational number. Now opposite to the rational number, a number that is not in the form of p by q or cannot be in a form of p by q is called an irrational number. Again the conditions remain same, where p by q are integers and q cannot be 0. Also, similar to the rational number, we need to check in the irrational number either the terminating decimal or the repeating decimal should not occur. Okay, let's take an example. You can write it like under root 2. Now if you solve under root 2, which is nothing but, I hope you know how to solve root values, 1, 1, 1. You get a reminder 1. I can also write in pair like this, 0, 0. You copy this 0, 0. Because of this decimal, you put a decimal over here, and then you write like 1 plus 1, 2, and then we know for the fact 2496. Now we got 4, and with this way, now you write this, then 4 and 24 is 28. Now you put 1 over here, and then you write 281, and then again you get something. So with this square root formula, after solution you will get a value of 1.41421335. Even if you continue this up to 50 decimal points, neither you will see any repeating pattern nor it is terminating. So this one you call it as a irrational number, or in a simple way you can say the square root of any prime number is actually an irrational number. But again the condition remains same, it cannot be written in a form of p by q, where p and q are integers and q cannot be 0. Also, neither it's a terminating decimal nor it's a repeating decimal. Okay. Now let's talk about our next topic, which is surds. Now, how do you identify if a particular number is a surd number? As you can see, under root a to the power n is a surd only if a is a rational number, and under root a n is an irrational number. Okay, for example, root 2. As per the formula, if I write it in a form of under root 8n, I can write it like this: 2 this, where a is equal to 2 and n is equal to half. As we know, a, which is equal to 2, is a rational number. Okay, as a whole, root 2 is nothing but 1.41, like we have seen in the previous example. So it goes on at least until 50 decimal points, and if you even continue dividing that, you will get more values. It is neither terminating nor recurring pattern, so we call it as a overall irrational number. So it satisfies our requirement, which is the whole number should be irrational and the number written within the root is a rational number. Similarly, if you see under the case of root 7, if I again write it in a form of a n, it's like root 7, a is 7, n is 1 by 2. Again, the value of root 7, as I explained you in the previous example, the values of all prime numbers, under root value of all prime numbers is irrational number. So that means my root 7 is irrational number. And my a, which is nothing but 7, is rational number. So as we can see, again, my whole number is the irrational number, but a, which is under the root, is a rational number. So then root 7 is also assert. Now coming to the next topic, which is rationalization of surds. So if the denominator of an expression is a surd, it can be reduced to an expression with rational denominator. Okay, so as we saw, what is surd? So if the surd comes under the denominator as a denominator, then we can actually reduce it in a fashion so that the denominator will become a rational number. Okay, and for that we call it the rationalization factor. So if a product of two surds is a rational number, then each of them is a rationalization factor of the other. Let's take an example. In a monomial surd, the rationalization factor of under the root a n is actually a to the power 1 minus 1 by n. As we can see in the example, the rationalization factor of under root 4 is under root 4. How did we arrive to this conclusion? Let's try to solve this. First, write under root 4 in a form of under the root a n. Here you can clearly see a is nothing but 4 and n is equal to half. As per the formula, the rationalization factor is a to the power 1 minus 1 by n, which means 4 to the power 1 minus 1 by 2, which is equivalent to 4 to the power 1 by 2. And 4 to the power 1 by 2 can also be written as under root 4. So here you can see the rationalization factor of root 4 is under root 4. Or in a simple form, if you find anything under root without any power, which is nothing but half, so then you can clearly say the rationalization factor is also the under root a. You also call it square root. Now the second example is binomial surd. The simplest rationalization factor of a plus root bn is a minus root bn. Let's take an example. So the rationalization factor of 2 plus under the root 5 is 2 minus under the root 5 as written here as a formula. Now how to prove this? Let's take an example. 2 plus under the root 5, if I multiply it with the rationalization factor which is 2 minus under the root 5 is nothing but 2 into 2 4 minus 2 under the root 5 plus 2 under the root 5 minus under the root 5 to the square. If I see, it becomes 4 minus 5 which is equal to minus 1, and I can clearly say with the definition of the rational number, minus 1 is a rational number. So the product of one number with its rationalization factor, if it becomes a rational number, then we call it these two are rationalization factor of each other. Hope you liked this video and understood the concepts of number systems. For more videos like this, please subscribe to our channel or register at gleanonline.com.